differentiation with us.
Okay, let's know about what is differentiation. Okay, now the meaning is differentiation is a fundamental concept in calculus that deals with finding the rate at which a quantity changes. Okay, let's say you have a function f(x). The derivative f prime x shows you how to fx is changing at any point x.
There are 6 technique differentiation. Firstly, sum and difference rule. For example, fx equals to x squared plus 2. The f prime x will be 2x. You have to apply basic rule, which is nx power of n minus 1. Secondly, product rule. The formula is dy over dx equals to uv prime plus vu prime. Thirdly is quotient rule. The formula is dy over ds equals to vu prime minus uv prime over v square. And next is chain rule. The formula is dy over dx equals to dy over du multiplied by du over dx. This formula is called Leibniz notation. And next is implicit differentiation. Implicit differentiation have 2 functions, which is explicit function and implicit function, which shows in the table. And lastly is linear approximation and differentiation. The formula would be f at 0 plus change x approximately equals to f at 0 plus f prime at 0 multiplied by change in x.
Okay, first let us look at the question 2a, which is y equals to exponent power of 3x tangent square x. For this question, we need to use the product rule to solve this question. So, first exponent power of 3x is u and tangent square x is v. Then, we need to differentiate each of them, which is for the u prime, we copy the exponent power of 3x, then differentiate the power. Then we got 3. The u prime will be 3 exponent power of 3x. And for v prime, we will differentiate the power and we get 2 tangent x. Then we will differentiate tangent x. Then we will get secant square x. So the v prime is 2 tangent x secant square x. Then we substitute them into the formula dy dx equals to u multiply v prime plus v multiply u prime. Then we elaborate them and the final answer is 2 exponent power of 3x tangent x secant square x plus 3 exponent power of 3x tangent square x. Then, let us move to the question 2b, which is y equals to cotangent x over 1 plus sin x. So, for this question, we need to use quotient rule to solve it. First, cotangent x is u and 1 plus sin x is v. Then, we will differentiate each of them. For u, after we differentiate cotangent x, we will get negative cosecant square x. Then, differentiate the x, we will get 1. So, the u prime will be negative cosecant square x. For v, after we differentiate 1, we will get 0, and after differentiate sin x, we will get cos x. So the v prime will be cos x. After we differentiate them, we need to substitute into the formula dy dx is equals to v multiply u prime minus u multiply v prime over v square. Then we will simplify them for the answer. The final answer will be negative cosecant square x minus sin x cosecant square x minus cos x cotangent x over 1 plus sin x squared.
Now, look at this question. Given ln 2y plus y sin 2x equal to x squared plus 3. Find dy dx using implicit differentiation. First,
we must to differentiate both sides of the implicit function with respect of x. As we know, for this question, we must to use product rule equation, which is u multiplied by v prime plus v multiplied by u prime. However, 3 cannot differentiate because there is no point x at 3. Second step, we need to allocate the terms with dy dx on one side of the equation. Next, we must to factor out dy over dx. After we factor out dy dx, we can solve the questions. So now we get the answer is 4x minus 2y cos 2x over 1 over y plus sin 2x.
Question 4. Cube root 7.99 minus 7.99 square. The solution is fx equals to x power of 1 over 3 minus x square. So the f prime x is 1 over 3x power of negative 2 over 3 and minus 2x. And x equals to 7.99 while x0 is 8. When you calculate the difference between x, you will get minus negative 0.01. Apply in formula linear approximation and differentiation. So you will get 8 power of 1 over 3 minus 8 square plus 1 over 3 multiplied by 8 power of negative 2 over 3 approximately equals to negative 62 plus 0.1592 and the last answer is negative 61.8408.
So now let me tell you the conclusion of differentiation. Different techniques in differentiation help us to find how a function is changing. Rules like the power rule, product rule, quotient rule, and chain rule make it easier to work with different kinds of functions. Knowing how to use these rules is important to solving problems in calculus and mathematics.